states there are 6 ionization energies of 4 elements A to D are given. Which element is most likely to be in group 4 of the periodic table? So you guys have to determine, looking at the ionization energy, which element is most likely to be in group 4 of the periodic table. So tell me, if it's in group 4 of the periodic table, right? So how many electrons should be in the outer shell? Khadija? Khadija, if any element is in group 4, how many electrons should be in the outer shell? Aruj, what do you think? If any element is in group 4 of the periodic table, how many electrons should it have in the outer shell?
4.
4 electrons, completely correct, right? So that means that in the outermost shell, I should have 4 electrons. 1, 2, 3, 4, right? So when I am finding out the ionization energy, right, I need to look at it in that way, that in which option the ionization energy is giving me the idea that there are 4 electrons in the outer shell. Now tell me, when I go from outer shell to inner shell, okay, what do I spot? What do I look at in the ionization energy? What do I notice? What information tells me that now I have moved from the outer shell to the inner shell? What do I look for? Do you remember what I told you? How can I tell? What will happen to the ionization energy? What do you think, Aruj? What should happen? If I'm making my graph, okay? So I remove the first electron, right? That's my ionization energy. Then I remove the second electron. That's the second ionization energy. Then I remove the third electron. That's my third ionization energy. I will remove the fourth electron. So my ionization energy is increasing, right? But it's increasing slowly. It's increasing gradually, right? Now, what happens when I go from the outer shell to the inner shell? What will happen to the next ionization energy? It will, Khadija, what will happen? What will happen when when I go in ionization energy? What did I tell you? When you go from outer shell to inner shell, what happens? How can you tell? How can you look at ionization energy and tell that you have gone from outer shell to inner shell?
It will like sort of take a jump.
It will take a jump. It will suddenly increase, right? It will suddenly jump up. The value will suddenly shoot up. First, it will be increasing slowly and gradually, and then it will shoot up. Since this element is in group number 4, so that means that the outermost shell should have 4 electrons. Once all 4 electrons have been removed, we are now going to go to the inner shell, right? That is making sense. We are talking about group 4. Group 4 has 4 electrons in the outer shell. So if that means that we are looking for an option where after we remove 4 electrons, after the 4 electrons have been removed, there is a jump in ionization energy. That is the option we are looking at. Because if an element is in group 4, that means it has 4 electrons in the outer shell. If it has 4 electrons in the outer shell, so when we go to the 5th electron, we will have a jump of energy because the 5th electron will be in the inner shell. So you have to choose an option where we can see this jump between the 4th electron and the 5th electron. What do you guys think? Look at the options in front of you. Aruj, can you see in any option where you can see a huge, and when I say jump, I don't mean a small increase, 2,000, 3,000, 4,000. I mean a huge jump.
Let's see.
C, you are absolutely correct, right? In C, between 4 and 5th, it suddenly goes from being 6,000 to 37,000, right? Which means that this over here, this is shell, the outermost shell, up to the 4th electron. After that, the energy shoots up, meaning that now from the 5th electron, we are in shell number 2. So in option C, the outermost shell has 4 electrons. So it's in group number 4. If I take a look at option A, in option A, what do you think? If I give this to you just to discuss, Khadija, what group do you think option A is in? Khadija, what do you think? What is A? Which group is option A in? Where can you see the jump? Can you see a jump?
Yeah.
Where? Where can you see the jump in group A?
After the first one.
After the first one, right? What does that tell you? That in the outermost shell, how many electrons are present in the outermost shell?
1.
1. So that means it's in group number
1.
1. Exactly. In option B, can you see any jump? Any huge jump that is happening? Is there any jump happening? No, right? It seems to be increasing slowly. 700, then 1400, then it seems to be increasing slowly, right? Doesn't seem to have a huge jump. What about option D? Khadija, can you see a huge jump in option D?
Yeah, after the
After the
5th one.
5th, right? After the 5th, we're seeing a huge jump in ionization energy. So option D, what group is option D in?
Group 5.
Option D must be in group 5. Exactly. So now this next time we get a question like this, you guys are going to do this on your own. Because now it should be clear how you can tell what group or what period any element is just by looking at ionization energy. In which species are the numbers of electrons and neutrons equal? We will go one by one. Okay. Let's start with this one, beryllium. Khadija, how many protons do I have in this? Tell me. How many
9.
protons in option A? Huh? Say it again.
9.
Khadija, I can't hear you say it properly. Aruj, can you tell me how many protons do we have in option A?
4.
Correct. How many neutrons?
5.
Correct. 9 minus 4 is 5. And how many electrons?
4.
4. Correct. So they're saying in which species are the number of electrons and neutrons equal? So in beryllium, neutrons are 5, electrons are 4. This is not the answer. Let's quickly move on to fluorine. In fluorine, Khadija, how many protons do I have?
9.
9. How many neutrons do I have?
10.
10. How many electrons do I have?
9.
9, because it's an atom. In an atom, the number of electrons and protons are similar to each other. So in option B as well, the electrons are not equal to neutrons. So option B is not the answer. We have to choose between C and D. Let's take a look at C. In C, Khadija, sodium, how many protons do I have?
11.
Right. How many neutrons?
12.
Correct. How many electrons?
11.
Aruj, how many electrons? It has a charge of +1. When anything has a charge of +1, does that mean it has more electrons or less electrons?
Less.
Exactly, less electrons. So how many electrons is it going to have? The charge is +1. So we will, whatever
10.
charge is, exactly. So you will subtract 1. If the charge is +1, you will do -1 with the protons. So you will get 10. So again, option C is not the answer because neutrons are 12 and electrons are 10. Now option D, oxygen, O2 minus. Khadija, how many protons?
8.
How many neutrons?
10.
How many electrons?
10.
Yes. How is it 10? The charge is 2 minus. When we have a minus sign, that means we have more electrons, right? If the charge is positive, we will subtract the electrons. If the charge is negative, we add electrons. So how many electrons do we add? 2, because the charge is 2 minus. So I will add 2 electrons to it. 8 plus 2 is 10. So the answer is option D, neutrons and electrons are equal to each other. Gallium nitride could revolutionize the design of an electric light bulb because only a small length used as a filament gives excellent light at a low cost. Gallium nitride is an ionic compound containing the gallium 3 plus ion. What is the electron arrangement of the nitrogen ion in gallium nitride? Nitrogen. What do you guys think? Nitrogen has a mass number, I think, of 14, and I think it has a proton number of 7. So what do you guys think? What should be the arrangement that we should make over here? What should be the electronic configuration? If it has got 7 protons, that means it has how many electrons? 7 electrons, right? So when I ask you to write down the electronic configuration, what is it going to be? Can anybody tell me?
It would be 1s2, 2s2, and then 2p3.
1s2, 2s2, 3p3. Fine. Now, their question is a bit specific. Their question is not about nitrogen atom. They're saying what is the arrangement of the nitrogen ion in the gallium nitride. So, let's take a look. The charge on gallium is 3 plus. What is the charge on nitrogen? Keep in mind that the formula of gallium nitride is GAN. What do you think is the charge on nitrogen? What should be the charge on nitrogen? That would give me the formula of GAN. What do you think? Khadija, what do you think? What should be the charge on nitrogen? What should I write down? What should be the charge on nitrogen ion?
I'm a bit confused.
Okay, hold on. Do you guys remember in IGCSE? Right? Let's take a look. If I have magnesium chloride, the charge on magnesium is 2 plus, the charge on chlorine is -1, right? You had studied in IGCSE that we will take the 2 and we will bring the 1 down. So the formula will become MgCl2, right? Remember, you had studied it like this, right? Now, okay, in fact, forget this. Remember this. This is a compound. What is the charge on the compound? 0. Do you guys see any charge on it? Do you see GAN2 minus, GAN2 plus? No. The charge on the compound is 0, right? The charge on gallium nitride is 0. Remember this. When we take the charges of the elements and we add them up, the total must be equal to 0. Okay? This is not true for ions. We do the topic of redox. I will explain this to you. But basically, this is a compound. What is the charge on a compound? A compound always has the charge of 0. Remember that. A compound always has the charge of 0, which means the total charge is 0. Now, remember this. The sum of the elements, when I take the charges of different elements and I add them up, the total should be equal to 0. The charge on gallium is 3 plus. Let's say that the charge on nitrogen is X. So 3 plus X should give me 0 because gallium nitride is a neutral compound. It has no charge. It is 0. So when I add the charge of gallium and when I add the charge of nitride, I should get the answer of 0. So what will be the value of X?
Minus
Khadija?
3.
Minus 3. That means that the charge on nitrogen is minus 3. Gallium is plus 3. Nitrogen is minus 3. They cancel out. We get GAN. Simple. Right? Now, after that, now you know that the charge on gallium is minus 3. Now tell me, Khadija, how many electrons will nitrogen have? The atom of nitrogen has 7 electrons. So if nitrogen has a charge of minus 3, when it becomes an ion, it gets a charge of minus 3. How many electrons will it have now?
10.
It will have 10 electrons. Correct, because you will add 3 to it. So now what will be the electronic configuration?
Yes, it will be D.
It will be D. Correct. 1s2, 2s2, 2p6. We will add 3 electrons to it. So the answer is option D. Good job. Get this, don't have to worry about this. Okay, skin cancer can be treated using a radioactive isotope of phosphorus. Okay, a compound containing phosphide ion wrapped in a plastic sheet is strapped to the affected area. What is the composition of phosphide ion? Aruj, can you quickly tell me how many protons I will have?
15.
Correct. How many neutrons will I have?
32.
Neutrons.
17.
17. And how many electrons?
18.
18, because we will add 3 to the proton number because the charge is 3. And since it says minus, so we will add it because it means we have more electrons. So what's the answer, A, B, C, D?
A.
Good, correct. The first 7 ionization energies of an element between lithium and neon in the periodic table are as follows. So we have an element. We have a random element that's between lithium and neon. Okay. They are telling you this is the electronic configuration. This is the ionization energy. They're saying, looking at the ionization energy, What is the outer electronic configuration of the element? First thing is first, looking at the ionization energy, who is going to tell me what group is it in? Who is going to tell me? Who wants to tell me what group is it in? Remember this, if you want to find out what group an element is in, simply look at the jump in ionization energy. Use the jump in ionization energy to figure out how many electrons are in the outer shell, and that will tell you the group number.
It's in group 6.
It's in group 6 because we go 1, 2, 3, 4, 5, 6. That means when we get to the 6th, after the 6th electron, there is a huge jump. That means that there are 6 electrons in the outer shell. So the electron, this is in group number 6. So in group number 6, we have 6 electrons in the outer shell. So in which of these options am I getting 6 electrons?
C.
C. 4 in the P and 2 in the S. 4 plus 2 is 6. Okay. Use of data booklet is, so data booklet, you have to use your periodic table. Which graph represents the number of unpaired p orbital electrons for atoms with proton numbers 13 to 18? Unpaired p electrons, what do I mean by that? Do you guys remember when I told you that our orbital is going to be px, py, and pz, remember? And I had told you when we're filling the electrons, first the electron will go to X, then to Y, then to Z. And then if you add more electrons, then they will go again to X, then to Y, then to Z. Right? Remember I told you that? So basically, when there is just one electron in X, Y, Z, all three of them, or not all three of them, one of them, whatever, as long as they only have one electron inside it, we call it an unpaired p orbital electron. That the p orbital, the electrons in the p orbital are not paired. There's only one electron in the px, py, or pz. Okay. Now they're saying which graph represents the number of unpaired electrons, p orbital electrons for atoms with protons number 13 to 18. Proton number 13 to 18. Can somebody quickly look at the periodic table and tell me what elements they are? What elements? Khadija, tell me, open up the periodic table and very quickly tell me. Proton number 13, what is it? Which element is it?
Yes, aluminum.
Sorry, Anuj, can you say it again?
Aluminum.
Aluminium, fine. And what is 14?
Silicon.
Sorry, can you say it again?
Silicon.
Silicon, okay, fine, correct. And then what's next? I am asking you because I don't have the periodic table open in front of me.
Phosphorus.
Phosphorus, okay. And then
Sulfur. Phosphorus.
sulfur, okay. And then 17 is chlorine and 18 is
Argon.
argon. Now, aluminium has 13 protons, which means it will have 13 electrons. So let's make the electronic configuration. What's going to be the electronic configuration? Let's go one by one. Aruj, you start off with aluminium, and then we will take turns making the electronic configurations.
One is 2, 2s2.
Fine. 1s2, 2s2, correct. Then
2p6 and
2p6, correct.
3s2.
Then you have made, yeah. Then 3p,
1.
1. And so 3p1, right? So px will have 1 and y and z will have no electrons because now we have protein electrons. Khadija, what's going to be the electronic configuration for silicon?
1s2,
Correct.
2s2,
Okay. More.
2p6, 3s2,
Yeah.
and 2p2.
Right. Tell me as x, y, z. 3px, 3py, and 3pz, right? So how many electrons in x, how many in y, how many in z? The p orbital will have 2 electrons, right? That's what you told me. 3p2, right? Khadija?
Yeah.
And if you remember, I told you that the electrons go one by one, meaning that the 2 electrons, both of them will not go to the x orbital. One will go to the x orbital and one will go to the y orbital. Remember, I told you that because of repulsion, right? The electrons prefer to go to the empty one. So they have 3 options. They have also x, they have also y, they have also z. So they will go one by one.
Yeah, so
So the
one in x
2
and one.
electrons will go one by. Yes, one will go in x, one will go in y. Aruj, can you quickly tell me what will be the electronic configuration for phosphorus? Khadija, meanwhile, you pick the electronic configuration for sulfur and argon. Aruj, so we are going to have 1s2, 2s2, 2p6, 3s2, and then after that, can you tell me what's going to be the electronic configuration?
Three px1.
Yes, correct.
And then
Then,
py1.
yes, and then,
And then pz1.
correct. Good job. Fine. Khadija, after that, can you tell me what's the electronic configuration for sulfur?
1s2, 2s2, 2p6,
1s2, 2s2, 2p6, then
3s2,
3s2, yeah,
and then in
3pxyz.
yeah. So in
So, yeah,
3p4 there'll be x2, y2. No, wait, sorry.
yes,
x2, y1, and
y1,
z1.
z1, right? Okay. Chlorine, Aruj, can you quickly tell me for chlorine? It will be 1s2, 2s2, 2p6, 3s2, and then what will happen in the 3p orbital, Aruj? P, X, Y, and Z.
px3.
Okay. Remember this, Aruj, X, Y, and Z, they can have
Yeah.
maximum of 2. That's it. So you can have 2 in
Okay.
X, 2 in Y, and 2 in Z. And then 2, 2, 2 becomes total of 6. So then the p orbital has total 6. So you have to basically draw 5, right? So from the 5, if to make it easy for yourself, always draw it like this. First, 1 in X, 1 in Y, 1 in Z. Now we have drawn 3, right? Now, 4. Where do I put the fourth one? Now the fourth one doesn't have any choice because all the orbitals have 1 electron. So it will go back to X. X will become 2. And now we have to make 5. And where will the fifth electron go? It can't go to X because X can have maximum of 2 electrons. So it will say, I have no option. I will go to Y. So this will be the electronic configuration. px2, p. Sorry guys, I got disconnected. Okay, I'll just quickly write it down again. For 13, it was 1s2, 2s2, 2p6, 2p6, and then 3s2 and 3. Okay, in fact, I'll write it down as a shortcut. In 13, we had 3px1, and then there was nothing in y, and there was nothing in z. And then we had 14, which was 3px1, py1, and then pz was empty. Then we had 15, in which we had px1, py1, and pz1. Then we reached 16, where we said it's going to be px2, py1, and pz1. And right now we were talking about 17, where we said that what's going to happen? We have to make 5 electrons in the p orbital. So they will, from the 5 electrons, 2 will go to x, 2 will go to y, and then only 1 will go to z. And finally, we have 18 electrons. That's our way. Khadija, can you quickly tell me the last configuration, x, y, z? What will I write down for argon?
Yeah, so it will be 3p2,
Yeah.
py2, and pz2.
Good. Now let's take a look at the question is saying the unpaired electrons we have to talk about. So in option in 13, how many unpaired electrons do we have? How many unpaired orbitals? In the p orbital we have is unpaired, right? In the px orbital, the px orbital is the only one that is unpaired, right? In 13, unpaired orbital. What's an unpaired orbital? In which there's only one electron. We don't have a pair of electrons. There's only one electron. So in 13, the 3px is the one that has only one single electron. Y and Z we will not count because they don't have any electrons at all, right? In option 14, Khadija, how many unpaired orbitals do I have?
2.
2, right? X and Y, both of them have one electron. We don't count Z because Z doesn't have any electrons. What about 15? How many unpaired orbitals and electrons in 15? How many
3.
orbitals have unpaired electrons in 15?
3.
3, right? X, Y, and Z. They all have one electron. So all of them have single electrons. All of them have unpaired electrons. What about 16?
2.
2, right? Y and Z. X is no longer unpaired because X has 2 electrons now. 2. And then we have 17. How many in 17, Khadija?
1.
1, the Z one, right? This is the only one. X and Y are now paired. They both have 2 electrons. And what about 18?
There are none. They're all paired.
There are none, right? Now we have to look for a graph that matches this shape. So we should see it should go 1, 2, 3 and then 2, 1, 0, right? So these two don't match, right? In this graph, so we need to see a graph like this. We need to see a graph like this, where it goes from 1, 2, 3, and then it reaches the maximum at 3, and then it decreases and comes to 0. We need to see a graph like this. So let's now look at a graph like this. Option A doesn't match our answer. Option B doesn't match our answer. We have option C and option D. And option D is exactly like the graph we just made. That from 13 to 15, it increases until it reaches the maximum at 15, and then it comes down. And at 18, there are no unpaired electrons in the p orbital. So the answer is option D. Making sense?
Yes.
Okay, now take a look at this one. Use of data booklet is relevant to this question. What could be the proton number of an element that has 3 unpaired electrons in each of its atoms? Let's solve. What could be the proton number? If the proton number is 5, that means the number of electrons are 5. If the number of electrons are 5, what will be the electronic configuration? Khadija, what will be the electronic configuration?
1s2, 2s2, and 2p1.
Right, 2s2, 2px1, fine. Okay, in option B, it's 13. So when the proton number is 13, the electrons will be 13. Aruj, can you quickly tell me what the electronic configuration will be?
1s2,
Mm-hmm.
2s2,
Mm-hmm.
and 2p6, and
Mm-hmm.
3p1. No, 3s2, sorry.
Yeah, correct. Good. The next one is 15, where the electrons are 15. So Khadija, quickly, what's the electronic configuration?
One is two, two is
Mm-hmm.
two, and then 2p6,
Mm-hmm. 2p6, then
3s2, and then 1 second. And 3p3, which is 3px1, 3py1, and pz1.
correct. Aruj, for electrons, 21 electrons, can you tell me the electronic configuration?
One S2,
Mm-hmm.
2s2,
Correct.
2p6, and 3s2,
Uh-huh.
and
After that,
this they doesn't have 2px, py,
yes, correct. Px is 2, Py is 2, Pz is 2, and then that's 18, right? We need to get to 21. After that, what do we write down
plus
after? Yeah,
4s2,
correct. And then,
then 3d1.
correct. So the question is saying, what would be the proton number for an element that has 3 unpaired electrons? Which option has 3 unpaired electrons? 5, 13, 15, or 21? In which one are we getting 3 unpaired electrons?
15.
15, right? Over here. X, Y, and Z all have only one electron. So these are the 3 unpaired electrons. 5 only has 1. 13 only has 1 as well. And same is true for option D. So option C, 15 is the correct answer. Now, next question is telling us what? Use of data booklet is relevant again to this question. The elements radon, francium, and radium have consecutive proton numbers in the periodic table. What is the order of their first ionization's energy? First of all, okay, Khadija, open the periodic table and tell me what is the proton number of radon, francium, and radium?
Give me 1 second.
Yeah, sure. Radon is 86, francium is 87, and radium is 88. So the proton number is increasing. Okay, proton number is increasing. Now, when we talk about radon, radon is in period number 6. That means it has 6 shells. And both francium and radium are in period number 7, meaning that they have 7 electrons in their outer shell. Now, when we talk about the process, what do we mean by least endothermic and most endothermic? Do you guys remember I told you that ionization energy is always positive? Meaning that whenever I want to do the process of ionization, I will always have to add energy. Ionization energy is always an endothermic process. Now, if the ionization energy is less, then it is going to be least endothermic, meaning that it's less endothermic because I do need to put energy, but not as much. When I have really high ionization energy, then that will be more endothermic. So they're basically asking you for ionization energy. Who will have the lowest ionization energy and who will have the highest ionization energy? That's basically what they are asking you. Now, what do we think? What do we think? First of all, let's try to take a look at which one of them will have the least ionization energy. When we take a look at ionization energy, I told you guys we will take a look at 3 things. Nuclear charge or nuclear force, shielding, repulsion between electrons. right? Over here, from the three options, which one of them will have the least shielding? Which one of them will have the minimum shielding? What do you think? I've told you which period they are in. Radon is in period number 6. That means it has 6 shells. Francium is in period number 7. It has 7 shells. And radium is in period number 7. It has 7 shells. So, based on shielding, tell me, based on shielding, which one of them has the least amount of shielding? Khadija, can you tell me which one of them has the least amount of shielding? Aruj, can you tell me?
Would it be radon?
Yes, it would be radon. The reason radon has least amount of shielding is because radon has the least number of shells. Both radium and francium have 7 shells. Radon has 6 shells only, which means that the outermost electron is going to be closer to the nucleus. If I compare it to radon and if I compare it to radium and francium, if I compare it to these two, so in radon, the electron is closest to the nucleus, right? The outermost electron is closest to the nucleus, right? And what about the electrons? Does in between these three, which one has the least number of electrons? Khadija, between these three, between radium, francium, and radon, who has the least number of electrons?
Radon?
Radon. So radon has less electrons, meaning that it has less repulsion, and it also has less number of shells, which means it has less shielding. So should the ionization energy be higher or lower?
Lower?
Think about it. If there is less repulsion between the electrons and the electrons are also closer to the nucleus because shielding is less. There are less shells in the middle. The electron is also closer to the nucleus. The repulsion between the electrons is less. That means they're not trying to get away from each other. Or they are trying to get away from each other, but not that much because there's less repulsion. Less number of electrons, less repulsion. If there's less repulsion, that means that they're not trying to get away from each other that much. On top of that, the shielding is also less. There are less shells between the outermost electron and the nucleus. So, if I want to remove that electron, do I need to use more energy or less energy?
More energy?
More energy, right? Because the strong attraction is stronger. The electrons are not repelling each other that much. On top of that, the electrons are close to the nucleus, so the force of attraction is really strong. So I will have to put a lot of energy to remove that electron, right? So that means following that logic, radon should have the highest ionization energy, correct?
Correct.
So that means, and I told you more endothermic means higher ionization energy, right? More endothermic means that I have to use more energy. So higher the ionization energy, the more endothermic it is. That makes sense?
Yes.
So that means radon is the one that is most endothermic. So either our answer is option A or option C. Got it so far?
Yes.
Okay. Now we have to choose between radon and we have to choose between francium. Okay. Now tell me, if I talk about the shielding between radon and francium, what can you say about the shielding? Khadija, I'm asking you, what can you say about the shielding? Who has more shielding? Who has less shielding between the radon and francium? Sorry, radium and francium. Radon, Rn, we have figured out that Rn is most endothermic. We have to choose between francium and radium now. Can you comment on the shielding, Khadija?
It would be the same, no?
It will exactly, the shielding will be the same because the shells are the same. Since the shells are the same, so the shielding is going to be the same. So there is no effect of shielding. Shielding is going to have no effect on the ionization energy. What about the electrons?
Radium has more
Radium
electrons.
has more electrons. Correct. Radium does have more electrons. Fine. Radium has a bit more electrons. Okay. Who has more protons?
Radium.
Radium. Radium has, okay, so francium has less protons and francium has less electrons as well. Now, just to give you information, if you, so generally nuclear force is quite strong, okay? Nuclear force is quite strong. Generally, when shielding is not present, if the number of shells are the same, so the electrons don't have much of an effect, okay? So you would say that, Miss, it has less electrons. So less electrons means less repulsion. So if there is less repulsion, I should put more energy, right? Because they're not repelling each other. So I should put energy to remove the electron. But since the number of shells are the same, the one number increase in electron is not that significant. Okay, just letting you know that even though the electrons, francium has less electrons and radium has more electrons, it won't really affect our ionization energy too much. Why? Because the number of shells are the same. Making sense, Khadija?
Yeah.
But okay, so we don't need to look at the number of electrons because the shielding is the same. Fine. Since the shielding is the same, electrons won't really have an effect. We need to look at the nuclear force. For that, we need to look at the proton number. Who has the lesser proton number, francium or radium?
Francium.
Francium. Francium has 87, radium has 88. So, who will have less nuclear force, francium or radium?
Francium.
Francium. So, who will have less ionization energy, francium or radium? Think of it this way. The stronger the nuclear force, the more energy I have to put to take the electron away. The less the nuclear force, the less attraction, the less energy I have to put. So, the more protons I have, the stronger my nucleus will be and more energy I have to give, right? So, between francium and radium, francium has less protons, which means that the nuclear force is less. So, do I need to put more energy or less energy to remove the electron?
Less.
Less energy, right? Because number of protons are less, nuclear is weaker. If the nucleus is weaker, so I don't need to put that much energy because the nucleus is not holding onto the electron very strong, right? That means between radium and francium, who will have less ionization energy? Francium, right? I don't have to worry about the shielding. Shielding is the same. They both have the same number of shells. So who will decide the ionization energy? Nuclear force. Okay? So, who has the weaker nuclear force? Francium. Francium has only 87 protons, right? So, less attraction, less energy I have to give to remove the electron. So, francium has less ionization energy. So, you and I decided that Rn, radon, has the most energy, right? So, this is the most. Now we have to choose between francium and radium. So between francium and radium, who has less energy? Francium. So francium will have the least energy, radon will have the most energy. And that is option
A.
A. Got it? Making sense, Khadija? Do you want me to go over any of this again?
No.
Are you sure you're the only one in class right now? You can let me know. You want me to go over any of this again?
No, I understand.
You are completely sure, right? Because this is
Yes.
really important. So these kind of questions you're going to get, and you are only going to be deciding based on the same thing you can see is getting repeated, right? The number of electrons, how many electrons are present, how many shells are present, and that's it. That's how you decide who will have more or who will have less ionization energy. Okay? All clear? 100% sure that there's no confusion in anything we have done so far?
Yeah.
Okay. Okay, Khadija, then we'll go ahead and we will stop it over here for today, and then we will continue practicing our questions in the next class. All right?